So finishing up the last couple of slides, Sassy Pants, we are going to get everything finished up. Covalent compounds. So like I said, we are going to look at properties of real compounds, covalent, ionic. So covalent bonds between atoms are strong, but their attraction forces are not. So an ionic compound we talked about over and over again, held very tightly together, hard to break apart, high melting point, high boiling point. Covalent bonds, the attractive forces are not strong, they're weaker, so they should be much easier to melt, to boil, etc. The weak attraction actually has a name, and it's called van der Waals forces. So that is the name of the attraction that holds the atoms together. It's not an ionic bond anymore, it's van der Waals forces. The forces are going to vary in strength, but they're weaker in a molecule than they are in an ionic compound. And I've kind of been guiding you towards that already, telling you how strong ionic compounds are. Nonpolar molecules have something weaker. It's called a weak dispersion force, or simply an induced dipole. What this means is that nonpolar are the weakest out of all of them. Nonpolar bonds, so like I said, grease is nonpolar. It might be hard to get out of clothes, but as far as like melting and things like that, it's not held together very tightly. It has a weak force. Force between two charges are called dipole-dipole, and that you've probably seen on that computer activity where we see dipole force. So dipole means that it has two charges. A hydrogen bond, so if you take advanced chemistry, we'll talk, hydrogen bonds are special. Hydrogen bond is the strongest, or one of the strongest dipole forces. So water has oxygen and hydrogen. To have a hydrogen bond, you have to have hydrogen. So water has a hydrogen bond. It has a strong force. So the hydrogen attaches to oxygen in water, which is why water is extremely polar. The attractive forces of water, if you put a drop of water, it like bubbles up. That is due to the hydrogen bonds. Water is very attracted to itself, which is why you also have streams of water that come out of the faucet instead of drops, unless there's very little water. So hydrogen bonds are stronger, they're found in water. And then many physical properties are completely due to those forces. Weak forces, so remember nonpolar is the weakest, result in low melting and boiling points. Many covalent molecules are soft solids. So even grease I would call a soft solid. When we were looking at ionic compounds, most of them are salts. They're crystals. They're hard. Well, covalent compounds, a lot of them are soft solids. Not all of them, because a diamond is actually a covalent compound, but most of them are relatively soft. Molecules can form a crystal or a crystal lattice, and that's what diamonds do. That's what makes them different. Quartz and diamonds are covalent, but they make these crystal networks. They're called a network solid, and that makes them much, much stronger. So if I have a covalent, strong solid, it's probably because they're interconnected. They form a crystal lattice, and we call that a network solid. So quartz and diamonds are exceptions to the rule. They're a network solid. They're still covalent. Their structure is just very, very netted, for a lack of a better term. It's held very, very, there's lots of bonds between them, and that makes them a stronger molecule. And that's end of this chapter. So we'll stop there.